EHV Current Transformers, presented by Sanjay Kumar Srivastav, retired DGM. Current transformers in extra high voltage system safely measure the protect high magnitude alternating current by stepping them down to measurable range for protective relays and metering instrument. Purpose and protection of EHV CT. First, system protection. Second, accurate metering. System protection. Detect overcurrents and abnormal conditions to prevent equipment damage and ensure system stability in high voltage environment. Accurate metering. Enable precise current measurement for billing, power monitoring and analytical purposes in EHV power system. How current transformer works. First, primary connection. Second, magnetic induction. Third, secondary output. In primary connection, primary winding connects in series with the EHV conductor carrying high current. Magnetic induction. EHV current creates a magnetic field through the electromagnetic induction principle. Secondary output. Proportional reduction current induced in secondary winding connection to the instrument. Key technical features of EHV CT. First, extra high voltage insulation. Second, core balance CTs. Third, accuracy class. Extra high voltage insulation, especially designed with high rated insulation, prevent electrical breakdown at extreme voltages present in EHV system. In core balance CTs, specialized transformers detect ground faults by sensing current imbalance in three-phase system. In accuracy class, defined precision in converting primary to secondary current under various load conditions, ensuring reliable measurement. Construction standards of EHV CT. Design type, terminal configuration and primary design. In design type section, single phase all immersed with class A insulation or SF6 gas filled, self-cooled per IEC 60044-1, available in dead tank or live tank configuration. Technical configuration. Secondary terminals brought out at bottom to weatherproof IP55 terminal box. All ratios provided at secondary taps. In primary design section, single primary of ring or hairpin type power frequency terminals provided to measure tan delta and capacitance. Voltage system specifications of the EHV CT. 765 kV, 400 kV, 220 kV. In 765 kV system, highest system voltage is 800 kV 6 by 5 cores configuration. In 400 kV system, highest system voltage 420 kV 5 cores configuration. In 220 kV system, highest voltage system is 245 kV 5 cores configuration. In 132 kV system, highest system voltage 145 kV 5 cores configuration. Thermal rating requirements of EHV CT. First, 765 kV system. Rated extended primary current 200% of rated primary on all taps except 3000 by 1 ampere 122%. At 3000 by 1 ampere, thermal rated 200% of 15 minutes 120% continuous. In 400 kV system, rated extended primary 200% on all taps except 2000 by 1 ampere. At 2000 by 1 ampere, thermal rated 200% for 15 minutes 120% continuous. In 220 kV and 132 kV system, rated extended primary current 120% or 150% on all cores as per requirement specifications. Accuracy and performance standards. Production class CT. Maintain required accuracy for burdens ranging from 25% to 100% of rated burden up to accuracy limit factor or knee point voltage. In metering core, maintains accuracy for current ranging from 5% to 120% of rated current or specified rated extended current, whichever is higher. Testing requirements of EHV CT. There are 4 types of tests. First, type test. Second, routine test. Third, acceptance test. Fourth, special test. In type test, radio interference, seismic withstand, thermal stability at rated voltage and extended thermal current. In routine test, standard testing as per IEC 644/1 specification for all manufactured units. In acceptance test, final verification including multiple chopped impulse and fast transient test. In special test, fast transient test to assess performances for high frequency over voltage during disconnector operations. Primary and secondary circuit requirements of EHV CT. Primary circuit withstand highest voltage continuously. Composite polymeric bushings, insulation, silver gray color. Third, test type of DDF and partial discharge tests. Fourth, aluminum alloy terminals with silver tin coating. In secondary circuit, normal secondary current 1 ampere for all secondaries. Second, continuous thermal rating 2 ampere for all secondaries. Third, fixed output voltage limiting devices with protective cover. Fourth, common output tap for principal and intermediate ratio. Salient features of EHV current transformer. Nominal or rated system voltage. 765 kV system. Rated voltage or nominal voltage is 765 kV. For 400 kV systems, nominal voltage or rated voltage is 400 kV. For 220 kV system, nominal voltage or rated voltage is 220 kV. For 132 kV system, nominal voltage or system voltage is 132 kV. In second step, we will elaborate highest system voltage. For 765 system, highest voltage system is 800 kV and 400 kV systems. For highest system voltage is 420 kV. For 220 kV system, highest system voltage is 245 kV. Highest system voltage for 132 kV system is 145 kV. In third steps, number of cores. There are 6 to 5 cores in 765 system, 5 cores in 400 kV systems, 5 cores in 220 kV system, 5 cores in 132 kV system. Fourth, rated current, primary current. For 765 system, rated primary current is 6 or 5 ampere. For 400 kV systems, rated primary current is 5 ampere. 220 kV system, rated or primary current 5 ampere. 132 kV system is 5 ampere. In this section, primary circuit requirements of EHV current transformer. Be capable of withstanding the highest voltage continuously. Second, be capable of withstanding the continuous thermal current and short time thermal current without exceeding the temperature rise limits as per the relevant applicable standard. Third, have composite polymer bushing insulation, silver gray in color, capable of withstanding all environmental conditions, including those imposed by fauna, heavy pollution, and salt spray. Fourth, heavy insulators with sufficient static and dynamic mechanical strength to withstand normal loads, operating forces together with electromagnetic forces produced from short circuit. Have a test tap provided for dielectric dissipation factor tests and for partial discharge test. The tap shall be brought out as a hermetically sealed test terminals housed in the secondary terminal box and connected to the earth through a slight disconnect like. The earthed shield shall be earthed through the test terminals and slight disconnected link. Sixth, not required reconnection of primary windings to obtain intermediate and derived transformation ratio. Seventh, if provided with dual primary conductors, be capable of series or parallel connection without access to internal links. Eighth, current transformers must be provided with aluminum alloy primary terminals with silver or tin coating suitable for connection to copper or aluminum conductors. The terminals must be supplied in the horizontal orientation. In this section, primary circuit requirements of EHV current transformer. Be capable of withstanding the highest voltage continuously. Second, be capable of withstanding the continuous thermal current and short time thermal current without exceeding the temperature rise limits as per the relevant applicable standard. Third, have composite polymer bushing insulation, silver gray in color, capable of withstanding all environmental conditions, including those imposed by fauna, heavy pollution, and salt spray. Fourth, heavy insulators with sufficient static and dynamic mechanical strength to withstand normal loads, operating forces together with electromagnetic forces produced from short circuit.